How are you all? I hope you are doing good and fine. My name is Amok Shukla and I will be your teacher for the upcoming class in the Vedantu. And I am looking forward to guiding the student just like you, my dear student. Before the starting the topic, please allow me to share a little bit about myself. Uh, I am from Jhansi and I complete my graduation as a BTech from DBT National Institute of Technology and Management. By taking the electrical and electronics branch as a specialization, I done too many projects in my academics time. So I wanted to share the project experience and knowledge to the line of teaching. My life passion is always become a teacher. So I instructed too many students in my previous time, which make me more than 1 year of experience. And here it is my first time one of the best teaching platform known as a Vedantu. I previously worked as a teacher for the responsible as a gifted program. Actually, my year of experience always guide me that how I can help the student and make them successful in their classroom and beyond. And second thing, I truly believe that student success begin with making them comfortable in the classroom. So I decided to show the plenty of experiment in which I including also enjoyment there. So we can make some joy and make the study well and with including the enjoyment also. So, and third one is this, I start to create the space for my student in which they can explore their own learning style. And I will be there guiding them and making them comfortable or absorption of the material. And fourth one is this, I also encourage the student that share their opinion and question in unbiased and open environment, and this way we can continuously grow our knowledge. So this is my introduction. Thank you to giving me the time for me. So now come to the topic of physics, which is very important to you, which is based on the 12th class and the basic and first chapter of the 12th physics chapter. So let me open the slide here. uh, so as you see in the left side of my screen, it is written as electrostatics. Okay, so what is the meaning of electrostatics here? So if you divide the part of electrostatic in the two, like electro and statics, you will see there is a electro means electric charge, right? And statics means at rest. So what is the meaning of this? The electric charge which is producing the electric field or the electricity when it is at the rest position, it is called a electrostatic. Some of the topic also relate to the electrostatic. You can understand in a better way to the topic also, like first is the fractional electricity, second is the properties of electricity, third is the coulomb's law, and fourth one is a unit of charge. If you go to the second slide, you will see there is a fractional electricity, right? So fractional electricity is an electricity produced by the rubbing of two suitable bodies and transferring of electron from one body to another. What does the really mean it is? As you see the example of ebonite rod or glass rod is also there, and the silk also, the cloth is also there. So what is the meaning is this? When you rub the cloth to the glass, the loosely bound of electron in the glass are transferring to the silk, and silk get possessing the negative charge, and the glass is possessing the positive charge. So it is the fractional electricity. So to know about the fractional electricity, consider a note here that the electrification of the body means it is the transfer of electron or the deficiency of electron possesses always the positive charge, and the excess of electron always possessing the negative charge here. So some of the example in the second side is this ebonite and funnel also there. So in the ebonite, there is a tendency of ebonite to gaining an electron here. So that's why it possessing the negative charge here. And phenol is also the tendency to losing an electron. So phenol is possessing the positive charge here. So some of the example like column 1 and column 2 here, a glass is possessing positive charge because the tendency of glass is the losing of electron, right? So it's mean that comparatively to the silk, it loses the electron of the glass, right? And the silk is always possessing the negative because it have a tendency or to gaining an electron here. So, and the second example is blue funnel, always positive charge, and amber, ebonite, rubber, plastic, always negative. So, ebonite is a positive also, and polythene is also in a negative. Sometimes the ebonite is compared to the polythene. You will see there comparatively ebonite is losing electron tendency as compared to the polythene. But in the wool and funnel, ebonite has a power to gaining electron as compared to the funnel there. And the last one is the dry hair is tendency to the coulombs. The form is also possessing the negative. And the fourth slide is this properties of a charge. So, what is the properties of charge? The first property says that there exist only the two type of charge, namely positive and negative. In the universe there is the only two charges exist there. It may be the positive and the negative. So when you deficient in the atom, there is a deficiency of an electron. It possessing the positive charge there, and the excess of electron, it's mean the negative charge. So the two charges exist is called the properties of a charge. So the like charge repel mean the positive and positive charge which are come contact. Apart from this, they are behaving like they are repelling each other, right? And if you talk about the unlike charge, means the positive and negative charge are come near, you will see there is an attraction between them. So these attraction you will see in the next topic called the Coulomb's force or the Coulomb's law. So now the third one is a charge is a scalar quantity. So what is the scalar quantity? It's mean that scalar quantity T. It's mean the magnitude is not there, and some of sorry, its magnitude are there, not the direction. So magnitude is there means there is a no direction of such thing like there is a particular direction in which you apply the charge here. It is not the way. Only the magnitude or the quantity there of the charge is called as scalar quantity. Charge is additive in nature. Means additive in nature, you can directly simply adding them or subtracting them to increase or decrease the power of a charge quantity. Means that assuming there is a full charge, if you increasing the electric field there, so you should at least do some apply some charge also and increasing by their adding of and charge also. So you can simply add and producing electric field and increasing this field according to their need. So and the fifth one is a charge as a quantized. Charge as a quantized. What mean the quantized? Means that charge is always producing at the quantized form. Means at the quantum form. Means that the packet of a quantum, it is in the form of packet of quantum. It is called a quantized. Like it is not in the continuous form. As you see in the light, also there is a chunk of part. In the quantized form in the light also it is the same here also that quantize also the part of here, it is a part of which is not in the continuous form. Like electric the charge of an electron is 1.6 into 10 to the power 19 here. So it is in the quantized form, so you can also say that it is in the integral like 1 2 3 4 5 6 7. Charge is conserved. What is the meaning of charge is conserved? As you see here in the part of second slide, that if you take the glass and silk as a one system there, so in the whole system before and after charge are the same. Means after rubbing you will see there is a charge, only the quantity of charge is let assume the 5. After rubbing the charge is also the same, which means it is a charge or it is the value of is 5. So it is the meaning of the charge is concerned. So the next topic is Coulomb's law. Yeah. So what is the Coulomb's law? The force between the 2 point of charge. Let assume there is a charge between them. Charge is putting it apart from some distance like r. So in between them there is a force. It may be the positive or it may be the repulsive force or the attraction force is there. Like strictly speaking, there is a written like Coulomb's law apply on the stationary point of charge. Means the charge which is at the rest position. It means that there is a particularly some forces exist there. Like it may be the positive or the negative. Like force is always proportional to the product of charge for q1 and q2, and directly proportional to the r square. So force is proportional q1 q2 upon r square. It means that if you take some constant here, so k is a constant to when force is equals to k is equals to q1 and q2 upon r square, where the k is the constant, or you can also say that k is a constant for force constant also. And there is a some more of information about the k, like epsilon naught is the permittivity, is you can say that permittivity of direct coefficient is given by there. And in vacuum there is a some changing of k is also there. And in medium is also according to the medium we can change the k value and the constant value, and er is absolute value here, which is er is a relativity, relative permittivity, right? So relative permittivity, it's meaning that according to the relativity, means the e is for the air electricity, and e naught is from the particular medium. So the relativity is when you take the calculation of relativity, er is equals to e upon epsilon. So E naught for the air is 8.8542 into 10 to the power minus 12 coulombs square Newton inverse per meter square. This is the some information about the constant. Unit of charge. The unit of charge is almost in the standard unit at a SI unit of charge is called the coulombs, and the force is of the Newton is also 9 into 10 to the power 9 Newton is according to K value. And some of the information also written here, like in CGS, the unit of charge is state coulomb, EST of the charge, and CGS of a static system, and K is equals to 1 upon K is the dielectric constant. And for vacuum, K is equals to 1. It means that force is equals to K1 and Q2 R square, where the K is equals to 1. Right. So this is the and some of charge is also there, unit also there. 1 EMU of charge is equals to 10, 3 into 10 to the power 10 ESU of the charge, and 1 coulomb of the charge is equals to 3 into 10 to the power 9 instead coulomb, and 1 AV coulomb is equals to 10 coulomb. So this is the way I have to teach you in the physics or in another subject, because I love to teaching, so that's why I choose the teaching here. So thank you all. Have a nice day. We will meet you soon.